English with mathematics and graphing lines. So what we're going to do first is brainstorm English words that mean the following. So addition. When we read different word problems, we're going to look for words that say maybe add or increase by, or the sum. Okay, subtraction, again, subtract, just like add, but this time decrease by. So decrease by some amount, or we're looking for the difference. And you can add some more to this list as well. Okay, so for multiplication, we'll look for multiply, we'll look for times, we'll look for product, but then we're also going to look for things like 2 times or 3 times. Okay, so look for words like triple or double. Okay, because for double, we know that we're going to multiply it by 2. And of course, triple multiplied by 3. Okay, division, we're going to look for divide. We're going to look for quotient. That's like the technical term for division. And then we're going to look for words like half, which is 1 over 2, or a third, which is 1 over 3. Okay, and then sometimes we can look for other things. If you see a root, we're looking for a square root. If you're looking for a square, you're going to take whatever number it is and square it. So times it by itself. And if you see the word equals, you're going to put like an equal sign, or the word is also an equal sign. Okay, and now we're going to talk about the difference between an expression and an equation. So pretty much an expression and equation look similar. The difference is that the equation has an equal sign. Okay, so an expression is just a mathematical phrase that may contain numbers, variables, and operators. An equation can also contain these 3 things, but it's specifically expressing that 2 things are equal. So maybe an expression equals another expression. Okay, example 1, write the following phrases as mathematical expressions. So expressions, there's not going to be any equal sign. Okay, so the value of 5 increased by a number. So when we see the word like a number, we can think of the letter N or the little letter X, whatever variable you want to choose for that. So 5 increased by a number. Okay, B, 1/3, we're thinking 1/3 of a number, so maybe 1/3 of N. Decreased by 6, so minus 6. Okay, 7%. So when we see 7%, we think of 7 and then a percent sign, but when we actually work with a percentage, we have to convert it into a decimal. So we're going to take that, we're going to divide it by 100. So 7% of a number, again, a number is that N. Okay, now the sum, so we think of a plus sign, of 4 times a number, so 4n or 4 times n, and 6 times a number. 6n, 6 times a number. So we're going to do the sum of these two. So we're going to do 4n plus 6n. Now for example 3, we're going to translate the following sentences into an equation using 2 variables. So we're going to do the same thing for example 2, but this time we're actually going to write full equations. So again, an equation is expressing that 2 things are equal, 2 expressions are equal to one another. Okay, 1/2 of a number, so we already know that that's 1/2 of n, is 10, so equals 10. Okay, 6 times a number, so that's 6n is, which is the equal sign, 4. Okay, the square of a number, so this is our number, and then square it, is 25. And 20%, so usually we would think 20%, but when we divide that by 100, 0.2 of a number, decreased by 5, so minus 5, equals 2. And those are mathematical equations. Example 3, what we're going to do is translate the following sentences into an equation, but this time we're going to actually use two variables. Okay, so Mario's daily earnings, so usually for earnings we use a capital E, are $80, so earnings are, which is, but a plural, are $80 plus, which is a plus sign, 12%, 0.12, commission on sales. So we can just call that S. Okay, and we know that E is earnings and S is going to be the sales, the amount of his sales. B, the cost. So usually we write capital C for cost. To rent a canoe is, that's where that equal sign comes from, $25. We need a plus, and then $5 per hour. So that'd be 5H. And of course, hour is H. Okay, mixing one mixture with another mixture. Okay, let's call one mixture X and the other mixture Y. So when we mix them, the amount of X plus the amount of Y, Sally has, so that's kind of like that equal sign, 20 liters of the solution. So amount of X plus the amount of Y equals 20 liters. And D, the area of a rectangle is 60 is, that's the equal sign, the area is 60 square centimeters. So we can either put area equals 60 or length times width equals 60. And we can use length times width because we know it's a rectangle. Okay, let's recall what a linear system is. So a linear system is two or more linear equations that are considered at the same time. So what we're going to take a look at is when we have an X and Y axis and we plot both of the linear equations, we're going to take a look for the point of intersection. Okay, just like in grade 9. And the point of intersection is a point where two lines cross. Okay, so that point is common to the first line and common to the second line as well. So let's actually put everything that we just did into an actual example. So Ian owns a small airplane. He pays $50 an hour for flying time and $300 a month for hangar fees at the local airport. Okay, so in 1 month, the cost is going to be $50 per hour plus that $300 flat fee for that month, right? C is going to represent the cost, and H is going to represent the hours of flying, number of flying hours. If Ian rented the same type of airplane at the local flying club, it would cost him $100 per hour. $100 per hour. How many hours will Ian have to fly each month so the cost of renting will be the same as the cost of flying his own plane? Okay, so we have two equations. The first one is going to be for at the airport. Let's put AP, airport. And the second one is like the local flying club. How we learn this in grade 9 is we have to actually go ahead and like plot both equations. Okay, so we're going to plot the cost. Oops. So cost versus the number of hours. Okay, so let's take a look at, so it's like $150 an hour for those two. So let's go up by, let's go 50s. 50, 100, 150, 200, 250, 300, 350, let's go 400, and I hope it fits on here, 450. Okay, and let's plot 1 hour, 2, 3, 4, 5, 6, 7, 8. We'll go up to 9. Okay, so the first one's going to be in purple. Okay, so the y-intercept, the B, is 300. So let's start at 300. And then every hour it's $50. So go over 1 and up $50. over 1, up 50, over 1, up 50, over 1, up 50, over 1. And I would just keep plotting this until you have enough that you are confident that you have the straight line. Okay, and always name your line with the equation. Now, let's do the other one in green. Flat out $100 an hour. Okay, so the y-intercept is 0, and then we're going up by 100 over 1. So 100 over 1, 100 over 2 hours. 3 hours is going to cost $300. 4 hours is going to cost $400. And then 5 hours, okay, approximately maybe here. Okay, and now we of course connect this with the ruler, and then this one's going to be C equals 100H. Okay, so what we're looking for here is we want to know how many hours Ian will have to fly each month so that the cost of renting will be the same. Well, right here at this point of intersection, the cost is going to be $400, and the number of hours is going to be 4. So the point of intersection is 4, 400. Okay, and you can write, therefore, at 4 hours, the cost will be the same at $400. Okay, let's just analyze this a little bit. When we look at cost, we look at this axis going vertical up and down. So less than 4 hours, this green is actually going to be more beneficial. Okay, so going with the local flying club. And then over 4 hours, this purple line is going to be more beneficial, and that's just going for at the local airport. Example 5, here's kind of an easier one because this example gives us 2 equations. So the equations of 2 lines are this and this. What are the coordinates for the points of intersection? Okay, so we're unable to graph the lines like this. So what we're going to do is we're going to put both of these equations into y equals mx plus b form. Okay, because this y has a negative in front of it, I'm actually going to bring it over to the right-hand side. And then this negative 1, I'm going to bring it over to the left. So x plus 1 equals y. That's what that turns into. Okay, when we look at this, I mean, you can rearrange it if you're not comfortable with that. You can put y equals x plus 1. This is the same thing, okay? The y-intercept is 1, and the slope is also 1. Okay. For this second equation, again, we have a negative y, so I'm actually going to bring that over, just so it's simply y equals instead of negative y equals. We're going to bring over this positive 2, and that's it. Okay, the y-intercept is this number right here, negative 2, and then the m is the number right in front of that x in this form, 2. Okay, for the slopes, you can always put them over 1. Okay, 2 over 1, 1 over 1. And now all we have to do is actually plot them. So let's do this one here in purple. We always need a reference point, so that's our y-intercept. So we're going to start at 1, and then what we're going to do is from there we're going to apply our slope. So up 1 over 1, up 1 over 1, up 1 over 1. Okay, we're going to apply our slope, and then when you're confident that you have enough points, we can connect those. We're good. Okay, and that one's going to be x minus y equals negative 1. Now, the next one, let's do it in green. We always need a point of reference, so that's going to be our b, which is negative 2. So again, that's on the y-axis, okay? X-axis, y-axis, that's our y-intercept. Now, we're going to apply the m, the slope, up 2 over 1, up 2 over 1, up 2 over 1. And there already is our point of intersection. Okay, so that's going to be 2x minus y equals 2. So this is going to be our point of intersection, and it's at the point 1, 2, 3, 1, 2, 3, 4. 3, 4. And that's it. Example 6, Brian and Catherine want to get internet access for their home. There are 2 companies in the area. So there's IT Plus, and they charge a flat rate of $25 a month. So we know that's a flat rate when we do the y equals mx plus b form. It is going to be our b. That's our flat fee here. Okay, so let's go c equals 25. So it's $25 a month. So in these questions, they get a little tricky because as soon as we see this for like per month, we're thinking of putting an M there. But we're going to quote this as 1 month for the entire question. Okay, and Techies Inc., so this is Techies, charges $10 a month, so that's their flat fee, plus $1 per hour for use. If Brian and Catherine expect to use the internet for approximately 18 hours per month, which plan is the better option? Okay, so I'm going to show you why this one gets tricky. So let's do every 3 is 5. 1, 2, 3. Let's do every 2 is 5. Okay, so that's 5, 10, 15, 20, 25, 30, 35, and I hope it fits on here. Okay, C equals 25, so that one's going to be in purple. So no matter what, they pay $25 a month. C equals 25. Okay, now Techies, let's do green. So this one's going to start at 10, so that's their flat fee. 25 was the flat fee as well. If you take a look here, right here, it's still the y-intercept. So, and then $1 per hour. Okay, so let's do every 5 hours. 5, let's do this in blue. 5 hours, 10, 15, 20, 25. Okay, let's go back to green. Okay, so for 5 hours is going to be $5, right? 5 hours, $5. 5 hours, $5. Up to 20, 5 hours, up to 25. And then we already have the point of intersection, so I'm just going to connect those. C equals 1h plus 10. Okay, so this point of intersection right here is 15, 25. So at 15 hours, the cost is going to be 25. Okay, so the question is if they're going to use it for 18 hours per month. So what we want to do is we want to look up 18. 18 is approximately right here. Which one's lower at 18? Well, we meet this purple line before we would meet that green line, right? So the purple is going to be $25, but the green would be approximately 30, right? So for $18 a month, it's going to be cheaper to go with IT Plus. Another way that we can test this is C equals 25, and then we just actually plug in the 18, and we can see that IT Plus is the way to go.